I'm Anil Kumar, and in this video we'll learn how to write domain and range from graph of the function. Now I should say relations, since this is not a function, right? So let me make this word as graph of relations, right? Okay. Now we have four different graphs here. They are all representing relations. This one is not a function, since if I draw a vertical line, it crosses at more than one point, right? So it fails vertical line test. So this one is not a function, right? Let's be clear. Anyway, we'll also write domain and range for this relation. Others are all functions, correct? Now let's begin by writing domain of the first function. Now this is kind of difficult since we have fragmented kind of a graph. So we have this arrow indicating that from -3 it is going towards the left, and then these open circles and these closed circles means at -3 the value actually is 4 and not 1. The open circle is not the value. So that is how you have to read these graphs. Now I hope it is very clear to you. You can pause the video, answer the question, and then look into my suggestions. Okay, so what is the domain of the very first function given to us? Here we can write the domain as, let me write here, domain of this function can be written as x belongs to real numbers where, what are the conditions? See, if you look at this point, so it is where x is less than, and since it is filled up, less than equal to -3. So we can begin from here, and then you can write union u or comma as you wish. We'll write comma, right? Then we'll look into this interval. Now since this part is already covered, we could have written up to -1 here, right? So I'm kind of changing this and I'm writing -1 now, since I don't want to add this value -3 to -1. At -3 we do have a value, so it becomes x less than -1. And here you find that at 1 it does have a value, so we'll say x is equals to 1, and then that segment is there kind of from 2 to 4. So we can say x is greater than equals to 2 and less than equal to 4, right? So that is how you could write domain of this function, correct? Now let us write down range of this function. Range of the function is all the possible y values. So what we see here is that it does have 0 and then it goes up to -4 from 1, correct? 1 is not included, so we can say y belongs to real numbers where y is from -4 to +1, right? So from -4, since -4 is included, we'll write less than equal to, rather greater than equal to for y, and it is less than 1, right? And because of this point, we have to include 2 also. So y equals to 2, and then this point gives us y equals to 4. So we could write this as y equals to 2, 4. Do you see that? So that is how you could write range of the given function. It's kind of complicated. You have to just take care of all the points in the function and then describe domain range. But I hope that helps. Thank you. Now let's move on to the next one. Now here we have a straight line here, a horizontal line. What is the domain range for this function? Well, the domain here is, in interval notation, you could write from -infinity to +infinity, or you could write x belongs to real numbers. There is no restriction at all, right? That is in set notation. And the range of this function is y is equals to only one value, which is 3, right? So y is equals to 3. That is the range. Every point in x is mapped to just one value in y, right? So in the range we have only value 3 in it, correct? So that is how you could write domain and range of this particular function. Now let's write domain range of the function given here, which looks like an absolute function with integer values. Do you see that? Now this pattern could actually continue, right? So it could be a pattern which continues. So let's consider this pattern is continuing forever, right? Like this. In that case, we can say that the domain of this function is x belongs to, these values are all integer values, right? So we can say x belongs to I or z. Both represents integers. We are not saying it belongs to real numbers, since in between they are not connected with a straight line. Do you see that? Or a curve. So these are points, individual points at 0, 1, 2, 3, 4 on the right side, and -1, -2, -3 on the left side. So in this case, domain is x belongs to integer, and the range could be written as, if you say y belongs to integer, where integer is greater than equal to 0. Is that okay? Since it's always non-negative. So that could be the range for this particular function. I hope this point is very clear to you, right? Now let's look into the last graph here. It relates to a relation. It is not a function, since it fails the vertical line test, right? So the values given here are, let's assume this point is 4 for the time being. Okay, so we'll assume this point to be 4. Okay, now if that is 4, in that case the domain is all the values inside. So we could write this as domain of this function is, in interval notation we can write this as from -4 to +4, and range for this function is from -4 to +4, right? It's also from -4 to +4. However, this is not a function. It's a relation which has all values from -4 to +4. I know it looks as a slightly more than 4, but let us assume this to be 4. And in that case, we are saying this point is 4 for us, okay? In that case, the domain and range for this function is from -4 to +4. I'm Anil Kumar, and I hope this example helps you to understand how to describe domain and range of functions which are sometimes not continuous. You can always share and subscribe to my videos. Thanks for your time.